Alright then, continuing with our discussion of radicals and surds, what we'll do in this video is a few more slightly complex, let's say, applications of radicals and surds, which is why it says simplify part 2. And what we're trying to do is we're trying to combine everything that we've learned and apply them to questions that test all of them together, all of those concepts together. So let's have a look at A, for example. At the moment, I'm looking to subtract, but there's nothing I can do. I can't combine them in any way because I don't have the same surd. So what I should try to do is I should first try and simplify and see whether in the process of simplification I can actually reduce it to one common radical, as it were. So let's get started. I realize again that I can write 27 as 9 times 3, and I desire to do that because 9 is a perfect square. So I start off, I say this 2 times 9 times 3 minus 3, and 12 I choose to write as 4 times 3 because again 4 is a perfect square. This is brilliant because now I can express 9 as 3 squared times 3 minus 3 expressed 4 as 2 squared times 3. Now I can pull out all the perfect squares from within the root to outside, so I can make this 3. I beg your pardon, I made a little mistake again. This isn't a 3, is it? This is a 2. So there, we fixed it. Now, pull the 3 out there. This becomes 2 times 3, and the remaining square root of 3 stays there. And here we have 3 times, pull the 2 out, 3 times 2, square root of 3, which I can then simplify. I'm continuing down here as 2 times 3 is 6, root 3 minus 6, root 3. Now I have the same radical, so I can make it 6 minus 6. Oh, that's just 0, so 0 root 3, which is actually just 0. Sorry about the little mistake there. It's meant to be 2. I hope I can copy stuff down correctly. Alright, looking at this one. Again, not the same surd, so my first instinct is geared towards simplifying it and seeing if I can come up with the same common surd. 4 root 2, nothing much I can do there, can't simplify it any further. But 32 I know is 16 times 2, so instead of writing root 32 I'm going to write root 16 times 2. Then I realize, oh, 16 is actually 4 squared, so this is 4 root 2 plus the square root of 4 squared times 2. Again, this is exactly what I want because I have a multiplication under the root and one of the factors is a perfect square, which then I can pull out of the root. So I have 4 square root of 2 plus, with the 4 pulled out, this becomes 4, and what's left inside the root 2. So I have 4 root 2 plus 4 root 2. Now I have the same radical, so I can combine these. 4 plus 4 is 8 root 2. Alright, let's look at this one. This is slightly longer. Same concept, just slightly longer because the numbers are bigger. But that's what always happens. So I have 2. I can express the square root of 75 as the square root of 25 times 3 minus 4. 12, as always, is 4 times 3 because 4 is a perfect square. 25 I know can be expressed as the square of 5, so this is minus 4, and 4 can be expressed as 2 squared times 3. Then I can pull the perfect squares outside as I've been doing all along, making this 2 times 5, right? Square root of 3 minus 4 times 2 square root of 3. I'll continue down here. 2 times 5 is 10, square root of 3. 4 times 2 is 8, square root of 3. So again, now I have the same surd, so it's 10 minus 8, 2 square root of 3. And finally, in this case, the last one here, let me switch color, let me do it in green so you can see the difference. 3 root 24 minus 2 root 6. Again, I'm asking myself, how can I express root 24 best? As in, how can I express it as a product of perfect squares? And I'm thinking 4 times 6 actually isn't bad, because 4 is a perfect square. So instead of writing root 24, I'm going to write square root of 4 times 6 minus 2 square root of 6. Nothing much I can do there, because there's no way I can break 6 down any further and express it as a product of perfect square factors. So this stays. I know 4 is 2 squared, so I have 3 square root of 2 squared times 6 minus 2 square root of 6. Now I can pull the perfect square out of the root, exactly like I've been doing up here. So it's 3 times 2 square root of 6 minus 2 square root of 6, which is actually 6 square root of 6 minus 2 square root of 6. Now I have the same surd, so 6 minus 2 is actually 4 square root of 6. And there you have it. Let's round off this video by doing some of the rationalization problems. Remember, rationalization is what you do when you don't want a root or a radical in the denominator of a fraction. And that's very simple. What you do is you multiply both numerator and denominator by the same radical, the radical that you want to get rid of. This then becomes 10 square root of 2, and root 2 times root 2 is actually root 2 squared, and as we all know now, the square root and the square cancel each other, and I have 10 square root of 2 over 2. Since it's all multiplication, I can simplify by saying 1 and 5. So I'm left with 5 root 2. Final problem. Again, I want to rationalize, so I multiply both numerator and denominator by the root that I want to get rid of. In this case, that's root 2. So I'm left with 2 times root 3 times root 2 over the square root of 2 squared. Recall from the rules of multiplication that if I have the same root, I can multiply, I can pull the 2 under the same root. So in this case, that's a square root, that's a square root, so I can write this as square root of 3 times 2. And down here, the square and the square root cancel each other. I have 2. So I have 2 square root of 6 over 2. And again, I can simplify, which means I can get rid of the 2's there, and I'm left simply with root 6. So there you have it. That's your quick recap, spread over 3 videos obviously, but I'm bound by YouTube's video limits. I can't yet upload any videos that are greater than 15 minutes, so I have to keep within the time limit. But this is your short recap, short refresher into radicals and exponents. I hope you liked it. If you have any suggestions, any feedback, please feel free to write it in the comment section. And yeah, please subscribe to my channel and I'll keep uploading more and more videos. Thank you.